Hi there, this is the totally novice machinist here. This is my 70-year-old Craftsman Atlas lathe that I picked up 4 months ago. Before that I have never used a lathe in my life, so I'm learning as I go along. When I bought this thing, it did not have a quick change gearbox, and I thought it would be awesome to go old school and change the gears around when you needed to change your feed rate. And that got old really fast. So I took the plunge, got a quick change gearbox, tore it completely apart, and got really lucky. I didn't have to change any of the shafts or the bushings. All I had to do was clean out about 50 years of crud, put it back together and oil it and adjust it, and it works fine. Anyway, my like everybody else with a Craftsman Atlas quick change gearbox, their biggest complaint is the slowest feed rate is not slow enough. Your slowest feed rate is 0.0042 or 4 thousandths and 2 10,000ths or 4.2 thousandths of an inch. And that's not slow enough for some really good finishes. In fact, it's been described as if you were threading something, that would be at 240 threads per inch. So anyway, I went online and found a few videos on how to cut the feed rate in half. And most of those videos say there's probably a way to cut that in half again, and then they don't tell you what that way is, or they never bothered to find out. So anyway, I had a whole set of quick change gears because I used to change it manually. So I had all those gears to play with, and I finally figured out how to cut it in half again. I got my feed rate down to 1/1000th of an inch per spindle revolution. So I'm going to show you how to do that. First, I'm going to show you how to cut it in half. Right here you're looking at the normal configuration that gives you all the gear ranges here, or the thread cutting feed rates. With this slide gear out, you get 1, 2, 3, you get these 5 rows here, you get 45 different speeds, and then when you shift the slide gear to the in position, that gives you the top row of really coarse threads. So that's how it was designed to work. But I'm going to show you how to cut that in half first, and I'm going to show you how to cut it in half again. So let's get to it. We'll just pop this one off here, pop these off here. Okay. First of all, we're going to take both of these apart here. Let me move the camera down so you can see what I'm doing here. Okay. We're going to take both of these apart. We're going to pull this 48 tooth gear off of here. And now what they say you need to do this is to buy one 24 tooth gear. I would suggest that you also pick up a spacer. I think you find the part numbers for those right here somewhere. And the spacer just keeps your 48 tooth gear that you're going to put on here first from sliding back and forth and rubbing on the side of your other 48 tooth gear, and keep you from chewing things up in there. I think I just lost a washer. Anyway, we'll find it here in a second. There it is. Okay, so to cut this in half, first of all we put the 48, one of the 48s by itself down here where it was. Engage it with the big fat gear that's inside your quick change gearbox. We're going to take the other 48, drop that nut on the floor. We're going to take that out. We're going to take the 40 tooth gear off completely. Put the 48 on here. Come on. There's 48. There's the 24 that we bought off of eBay. This one doesn't like to slide well. Come on. There we go. Let's try it from the other side. Yeah, it works better from the other side. I believe the proper nomenclature for this piece here is the bushing. This is the sleeve, this is the bolt, washer, nut. And we're going to cover those a little bit more in a bit. Okay, we're going to put that together with the 48 and the 24. If you haven't figured out by now, 24 is half of 48, and we're cutting the speed in half. Okay, we're going to slide that down here so that the 24 back here engages with the 48 on the bottom. Tighten it down. And boom, we've cut it's a little tight. We've cut the feed rate in half. So your slowest feed rate is now 2 thousandths and 1/10 thousandths per revolution. So this is now D, this is now C, this is now B, this is now A, and you don't have an A in anymore because you've lost the ability to slide those back and forth. So you've lost your top 2 rows of threads, but you've gained that slow feed rate down there. So, all right, that's it. Now, let me show you how to cut that in half again. We're going to take these back off. We're actually going to leave these configured just as they are. All we're going to do is take that spindle out, or excuse me, take the sleeve out, put it back in on the other side. Washer, nut. Okay, we'll set that here. We're going to take our 48 with the spacer and do the same thing. We're just going to pull the sleeve out, stick it in the other side, and we can start putting this thing back together. Okay. Now before I figured this out, I tried all kinds of crazy things. I tried just doing it with one set of gears. I tried a 96 and a 24. That wouldn't fit in here anywhere. Not even sure what that goes to. Might be a 6-inch. And I've tried different combinations of 64s and 32s. Couldn't get those to work out quite right. So the way I'm showing you here is the only way I could figure out to do it, along with having to buy the fewest number of parts. So we're going to take our 48 and spacer, stick it back in on the bottom slot, right there, engage it with the fat gear on the back side of the quick change gearbox. Tighten that down, that spins good. We're going to slide this one on, going back on the top slot. We'll get that backlash pretty good. There we go, tighten it down. Okay, that's kind of where we were before. Now, we're going to take that 40-tooth gear that we had set aside before, and here's what you're going to have to get. You're going to have to get a 20-tooth gear, and you're going to have to get a whole nother bolt, nut, washer, sleeve, and bushing combination. Now if you go on eBay and type in Craftsman, Lathe, bolt, nut, washer, You get about 4 or 5 of these things to pop up, and they're running about 35 to 40 bucks for this whole setup. And the part numbers are here, the individual part numbers are here. This unit together doesn't have a part number of its own, but if you type in bolt, nut, washer, you'll get a couple of them pop up. And then you're going to have to get the 20-tooth gear. Make sure you get the right one for the Craftsman Atlas 10-12 inch. It's got the 2 keyways in it. So we're going to take that, pull it apart, and we're going to put together another combination gear with 40 and 20. Notice 40 is half of, or 20 is half of 40, so you got a pattern going here. Got 20 and the 40 together. Slide that in here on top again. Now you've got a couple of spots here where you got to be really careful. Let's get that tightened down almost. Okay. Now, if you notice right here, these two are not supposed to mesh. You want the 20 to mesh with the 48 back here in the back. You don't want these to hit right here. So what I do is I take a 6-inch steel rule, kind of slide it down there in between them. You could use a feeler gauge or something else. And that you want those as close together as you can without them hitting each other. If you get them too close together and you turn this thing on, it will definitely let you know with a bunch of loud banging and clanging noises. Okay, so those are not touching. You just want them as close as you can. Tighten those all down a little bit more. Now we slide this up here so that this engages with the 16-tooth gear. And again, you've got another spot for interference. You've got the 20 on the back here wants to hit the 32-tooth gear up here, and if you put that up there too tight, they'll hit each other. You just drop that down just a hair, and there we go. You've cut that speed rate in half again, so you've cut it by a factor of 4. Okay, let me just show you that it runs like this. I'm going to run it with the covers off so you can see what's going on. And there it is, runs nice and smooth, as advertised in your spindle, your feed rate is cut by a factor of 4, 1/1000th of an inch per revolution of the spindle. Okay, let me move the camera around and we'll show you some stuff up front. Okay, I've got the camera moved around here. Got a dial indicator set up so that it's on the carriage. I've taken the backlash out of the gears. I had to make this nifty little piece of cardboard here because my lights shined on that dial indicator so much you couldn't read it. So I've got a little shade on there. Hopefully you can see it. Anyway, and this dial indicator is 50 thousandths per revolution. So each one of these major ticks is 5 thousandths. So if we're getting 1/1000th per revolution, if I turn this around 10 times, I should get 10 thousandths of an inch, correct? So let's go right here with the with the input on the chuck. We can turn that around 10 times and see what happens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it looks like we're sitting right there on 10. Actually, it's just a hair past it. Because if you actually do the math on the if the original slowest one was 4.2 thousandths per revolution, you cut it in half and you get 2.1 thousandths per revolution. You cut that in half and you get 0.00105. So that little bit past there is that 0.00105 out in the 100 thousandths position to the right of the decimal point. Anyway, so at 500 RPM, it should go 500 thousandths in a minute, half an inch. So in 30 seconds, it should travel a quarter of an inch. So on this dial indicator, that's 5 times around. It's 50 thousandths, 5 times around, 250 thousandths. So let's give that a shot here. We've got to engage all kinds of things here, don't we? There we go. Try that again. Okay, when it comes around to 0, we'll hit start. There's 1. 2. 3. The spindle looks like, or that carriage looks like it's hardly moving. 4. And 5. There. We got 29.43 seconds of a highly scientific experiment there. Okay, so there it is. Proof that it travels at 1 thousandths per revolution. Okay, well, let's talk about your threading now. Okay, like I said, we lost, let's get that in there. We lost the top one and the second one down, going to a half speed. Going to cutting that half again, we just lost the next line there on the thread chart. So the coarsest thread you can cut in this configuration is 32 threads per inch. In other words, your spindle chart now looks something like that. Okay, your smallest thread is 1/1000th of an inch, or your slowest spindle speed is 1/1000th of an inch, and your biggest, coarsest thread you can cut is 32. As a matter of fact, I printed one of these just like that, and I keep it right there. So then I don't have to do any figuring in my head. I just look at that and pop it in gear where it's supposed to be. So, and if you want to cut any bigger threads, it is so easy to change that back. Let me move the camera again and show you how fast you can swap that back to the original configuration. Okay, if you want to cut some of these bigger threads, in other words, if you want to cut anything bigger than 32 threads per inch, it is really simple to swap this around and get it back to the original configuration without the slide. And there's a way to do that. There's another way to do that if you want to cut those really big threads. So let me see how long this takes. We're going to pop these off. Drop that down, slide that off. We don't need that for this. I'm going to slide this one off, and all we have to do is turn take the sleeve out of here, put it in the other side, put it back together, and slide it back on so that this 48 engages with that 48. We'll pop this up here against the 16-tooth gear. And there you are. You are now able to grab this, cut all of these threads here without the top line. You can't cut the top line. Now if you take this one off and just turn those around, engage it with the 32, now you can do the top line. To Go back again to the slow feed rate. Drop that down. Take this one back off. Turn it around. There we go. Take the 40-20 combo, put it back on. Get your 6-inch rule out again, or whatever you're using to get that space. Not too tight. And there we are. All it takes is a 40 and a 20, 48 and a 24, 48 and a spacer. You can cut your feed rate. If I leave mine like this all the time, when I do want to cut some threads, it takes less than a minute to flip it back around. So I hope you enjoyed the video. I hope it helps some people out. Thanks for watching.